So you can
This
also
meeting is being
utilize
recorded.
to the BIPV system. Then the window. So this is the window from there, and with the help of that, you can also using to the BIPV system and the setting. So some part we have using to the shading analysis. So that particular shading will be utilized from the system. So this is the classification. If you're talking about to the roof, so there is a different type of roof will be making out. So there is the discontinued roofing. So this is the continuous roofing. Like that, you have using to the all module in the entire roof, or maybe you can using to the skylight view. So this is the first example. If you seeing the facade value, so there is the rear screen facade, double screen facade, curtain wall, window, and masonry wall. And if you're talking about to the external integrated devices, so we will using to the parapet, solar shading, canopy, and the blue street. So this is a different classification of the BIPV system. Now, this is a typical example of the BIPV system. So you can see that this is the discontinuing roof. So you can utilize the system in this particular area. If you're using to the BIPV this places, so this is called to the continuous roof. If you're talking about to the skylight, so in your gallery or somewhere, you can also utilize to the BIPV system. If you're talking about the parapet, so also you can utilize to the BIPV system from there. Then the blue state, you can also utilize the BIPV system from here. And this is the Renaissance facade. So this is the main wall. You can also utilize to this BIPV system from there. Then the curtain walls. So from this particular place, you can also using to the BIPV system. So this is the different example of the BIPV system where we can utilize to the system in a different way. So this is the beauty of this BIPV. You can using to this technology in anywhere or any place from your requirement. Now we come to the benefits. So what is the benefits of the BIPV? Can anyone tell me what is the benefits of the BIPV? Any idea of anyone? So after you seeing this lot of figure and picture, so can anyone tell me what is the benefit of BIPV? Okay, no worry. So the what is the benefit? The first benefit is the energy efficiency. So whenever we using to this particular system, so we are using to the renewable energy on that particular location, and this will be utilized from the reducing the fossil fuel things, and also it will be lowering to the energy bill. So that is the first benefit of the energy efficiency. So if you're using to the BIPV system, it will be very well covered to the energy efficiency system. The second one is the aesthetic integration. So you can using to the different type of customized color, shape, texture with the architecture design. So if you're making a any building design, so you can using to the different type of colors, shapes, and the texture from this particular location. Now, the another thing is the cost effectiveness. So, if you're talking about to the traditional building material, so this will be the BIPV will be using from the long term energy saving, and this is a good for the ROI. The ROI means return of investment. So whenever the you have put the some money from your plant, so this is the come under the return of investment criteria. So this is a very cost effective product from there. Now, the environmental effect. So, this is a very important part from the benefit of BIPV. So, if you use it to the BIPV system, so it will be reduced to the carbon footprint, and it's also support to the green building certified like the LEED. So, lot of LED, the GRIHA, lot of certificate is there. So, we will also cover in the upcoming slide. Then space efficiency. So, if you're talking about to the urban areas, so there is a very limited space. So, if you're using to the this particular technology, so we can not using to the additional land for the generation of electricity. So you can only putting this module in your facade or window or somewhere and in roof, and with the help of that you can generate the solar electricity from there. Now this particular picture I just show you what is the demand will be happening in India in a 2047. So if you see this particular demand, so 59% of the energy demand will be coming to the building sector. So like the building sector is like the cooling, heating and everything. So this 59% of the energy demand will be required in the 2047. And if you're taking out the electricity demand in a 2047, how many terawatt hour? So this is also the 38% on the building structure. So this is the very right time and this is the alarming time, because in upcoming time the lot of energy demand or electricity demand will be coming to the building sector. So that's why the BIPV is the very right solution from this particular to minimize the energy demand and the electricity demand from the India. Now, any question from anyone till now? Okay, so you note down the question. At the end of the session, we will discuss the question answer session with you. I'm audible or not? Can anyone confirm me?
Audible, sir.
ओके ओके थैंक यू बिकॉज देयर इज नो रिस्पांस ना ये वेबएक्स में कुछ पता नहीं चलता एक्चुअली प्रॉब्लम ये है ओके
सर क्लियर ऑडिबल नो प्रॉब्लम
पार्डन
क्लियर ऑडिबल सर नो प्रॉब्लम
ओके ओके थैंक यू वेरी मच थैंक यू. Now we come to the photovoltaic technology. So this is the major technology. How to start with the photovoltaic technology? So first thing is the cell. So this is the cell structure. Then we will making to the cell string. This is the different type of cell when combined to each other. So this will making the cell string. And then after we make the module. So this is the solar module. You can see that. And whenever the lot of module are using to the series and parallel combination, so that will be called to the module string and array. So sometimes this is called to the array and sometimes it's called to the module string. And when the module are connected to the each other either in the series and parallel combination, so that will be the distribution of the generator methodology. So I'm just giving to the glimpse of this particular technology. So how the technologies look like. So this is the batch of the solar cell. You can see this. This is the all the solar cell is here. After the solar cell, we are making to the string. So this is all at the string we are making from here. And after the string, we are making to the module. So this module are coming from this way. And finally, the module are manufacturing. So it will be look like from to the this particular structure. So this is the behavior how the photovoltaic technology will be work out. So this is a cell to module process, and this is a factory inside. The photo will be taken from the Austria. From the Wyden. So this the same technology we are also using to the Indian solar industries like the cell string module connection, and finally we make the module from the system. Now, when we're talking about to the technology, because whenever we're talking about to the module, so there is a different type of technologies available. So when we're talking about the photovoltaic technology, we have to the three different technology. One is the crystalline technology, the another is the thin film technology, and the third one is the emerging technology, which for the coming in the upcoming year. So when we're talking about the crystalline technology, so we have a two type of technology. One is the monocrystalline solar module, and another is the polycrystalline solar module. So you can also see that the difference. If you see the monocrystalline module, so there is some gap on the module. But if you see the polycrystalline module, this all are the brick form. There is no cutting edge. There is no edge cutting in the polycrystalline module. Now, when we're talking about the thin film,
इधर आओ दोनों तुम दो जने इधर आओ आगे
pardon, hello.
No, sorry for the interruption. One of the participants opening.
Okay. So this is a thin film. Thin film is basically the different technology like the amorphous silicon, cadmium telluride, micromorph, and the different type of tandem technologies there. So this is the technology from the amorphous silicon and cadmium telluride. Now the emerging technology. So now the organic material is also coming in the market. The desynthesized solar cell is coming there, and the perovskite. So this is a new, very emerging technology will be coming here in the market. The perovskite module, the efficiency is more than 26 to 27%. So now the day the technology are using, and the Reliance is using to the HDT technology. This is one of the advanced technologies available on the system. So this HDT technology is the combination of the monocrystalline as well as the amorphous silicon. So this is the combination of this both the technology, and that is called to the HJT. HJT means heterojunction intrinsic with thin layer. So this is the emerging technology which is the Reliance has working on the this particular technology in the entire worldwide, and only the Reliance has the key player in India who is working to the SGT module technology, because this is a combination of crystalline as well as the amorphous silicon basic. Now we come to the BIPV design flow. So what are the design flow will be coming here? So when we discuss about to the building design, so the first thing is the PD. The PD means the preliminary design. Then we go for the SD. SD means symmetric designing. Then we go for the DD. This is called to the design development. Then we go for the CD. That is a call to the construction document. Then we go for the BP. That is a call to the building permit. Then we go for the BN, there the bidding and negotiation, and then finally we go for the CA, that is the construction and administration. So now this is the building design, how the BIPV design stage will be there. So the first step, why the BIPV will require. So we have already discussed that if you want to reduce the electricity bill, if you want to make the maximum efficiency of your system, so you can utilize to this system. Now the step one will be come to the building site. The first you decided to the site where you want to install your system. So this is the first step, and here the two activity in the come to the prelim design, why the BIPV and what is the building site from there. Now, the step two in the BIPV, the solar assets study, because the solar is also important. You cannot use to your BIPV building as location where the lot of shading will be coming there. So what will be happen if the shading will become that particular location? So you cannot generate it to the optimum amount of energy. So that solar assets study is also important from that particular aspect. The step three is go for the generation target. If you're using to the solar BIPV module, so how much generation will be happening on that particular location? Then we go for the step four, that is a call to the energy yield estimation, how much the energy yield will be coming from there. So these all are the steps will be done by the simulation software. So I will come in the upcoming slide, so I will also guide you how the simulation software will be look like. And after the simulation software, after this all the data like the solar energy generation, the target and energy yield, we go for the BIPV design, and then we finally we go to the step 6 where we will discuss about the sustainability and the cost of the system. Because if you put in the BIPV and still this is not the cost effective and is not the sustainable, so there is a no role for the BIPV system from there. So that is the design step from the building design stage, and this is the BIPV design stage. Now, this is the one example how the roof will be integrated in the different way. So the first roof protection from the primary protection such as the rain and snow. So whenever you're using to the BIPV system, it will be required. The protection will be happening from the rain and other thing. Then the another protection is the thermal and the solar protection such as insulation, the sun shading, and the day lighting. Because if the shading will be coming there, if no proper insulation there, so your BIPV is not working in a proper on that particular condition. Now the protection is against the falling such as the balcony and parapet. So you can also adjust the system in a proper way. Otherwise, if something will be falling from that particular location, so it will be damaged on the lot of things from there. So this is a protection against the falling is also important from the integrated building designing system. Now, after to the introduction of this particular BIPV, we will discuss about to the BIPV in Indian solar policy. What are the solar initiative has done with the ministry and the other part. So the first thing in the solar policy. So you have already aware that India has taking the aim around the 300 gigawatt of the solar capacity in a 2030, and for that particular constraint we have required the land also, okay, because the solar panel have using to the land. So for the BIPV we have using which is the given a proper solution where we have the land neutral solution from the system, and we can also use into the solar module in the mounted and the rooftop system. So this is the first initiative taken by the government of India from the importance of the building structure. Now the government initiative has taken here. So the first initiative is the, yeah, any question from anyone? Any question?
No, sir. No, sir.
Okay, so the first initiative from the government side, that is the PM Surya Ghar Muft Bijli Yojana. I will also give the some background of this Yojana, and this is the particular Yojana will be started in a 2024, and it will be included a lot of subsidy like the BIPV system and the other things. So I will come to this particular thing. Now, apart from that, the government has also allocated some fund under scheme of innovative project. So the innovative project will become under the BIPV technology. So if you go to the DST side or the MNRE side, so you will find out some detail regarding from this system. Now we come to the PM Surya Ghar Muft Yojana, and this is a very important initiative initiative done by the government of India. You can also utilize this particular Muft Bijli Ghar Yojana for your roof and your site, because this is a very subsidized rate from here. So if you're talking about the PM Surya Ghar Yojana, so basically this is the Muft Bijli Yojana where the 1 kilowatt of system, the subsidy will be provided to the 30,000 rupees. If you go for the 2 kilowatt of system, so the subsidy is provided to the 60,000 rupees. And if you're putting the 3 kilowatt of system or higher, so the subsidy will be given around the 78,000 rupees from there. So if you're talking about the 1 kilowatt of plant costing, so it will become around the 50 to 55,000. So means that the 30,000 rupees will be given by the government, and only you will invest around 25,000 rupees, and with the help of that you can utilize to this PM Surya Ghar Muft Bijli Yojana for you in your room. So this is the different segregation, but above the 3 kilowatt there is no subsidy from there. So up to the 3 kilowatt, the 78,000 of the subsidy from there on that particular system. Now we're talking about the policy recommendation. What are the policy will be coming in the BIPV system? So the first policy is the National Building Code. So this particular building code is available on the BE website. You just go there and just download from there. Then the another is the energy conservation, the conservation building code. So this is also you can find out from the BE side, and the Eco Nivas Sahita. This is the standardize and promote to the BIPV adoption. So this is the three initiative has taken by the government from the building code, the energy conversion building code, and the Eco Nivas Sahita from there. Now the different type of target and subsidy initiative has done by the commercial and industrial sector. So we have already seen that in the commercial and industrial sector we have using to the different type of the Muft Bijli Ghar Yojana from there. Now the promoting to the domestic manufacturing. So the lot of PLI. So you have heard about to the PLI. The PLI is basically the production linked incentive scheme is there, and with the help of that, the lot of the fund will be given by the government on the private company. So with the help of that, it will be reduce the cost, and is also Reliance to import the system. So this will be the initiative has taken from the BIPV. The encouraging the demonstration project and the public infrastructure like that school, airport, data center. So these are the some project where we have using the system, and this will be the helpful for the scalability and the different types of benefit of the system. Now, apart from this particular policy, so a strong BIPV system will be also required from the integrated technology, and also giving the comprehensive roadmap solution and minimize the inefficiency of the system. Now, the BIPV benefits with the local industry that will create the different job and enhancing the energy security, and it is also come to the Make in India initiative apart from this particular thing. So if we promote to the in-house productivity, so the lot of scope, lot of job will be also created from there. Now, the Central Public Work Department, that is a call to the CPWT, is also coming to the initiative of the BIPV project, and they have making the last couple of years lot of project in India. I will show you in upcoming slide what are the projects from there. The government programs would expand the clean energy target, and it is also giving to the lot of benefit from the large scale BIPV development and the commercial building from there. The policy is also come from the capacity and the building initiative, including to the training, such as the architecture and the policy maker, and lot of development of the skilled workforce. So this FDP program is also the one of the capacity building initiative done by the NIT. So this is the very good scope. You can learn the new technology in new way. Now, the policy recommendation is come under the BIS because the BIS is the Bureau Indian Standard, and it is also given to the expertise of the specific standard. While the green building certification like the GRIHA, GEM, and LEED, and other things from there, and a lot of BIPV promotion will be happening from there. Now, the most important from the policy recommendation is the public-private partnership, and with the help of this particular partnership, we will do the innovation and a lot of support from the local manufacturers. So this is also a very important initiative from there. So this is the different policy recommendation. Now, there are some challenges also on this particular technology. So the till now we have discussed about to the advantage, but there is some challenges. So what are the major challenges in this BIPV technology? So now the first thing is the high upfront cost. So if you're talking about to the initial investment in a BIPV is higher as compared to the traditional building or the material from there. The second one is the lack of dedicated policy. So absence of the comprehensive policy and the financial initiative will be also leaking to the BIPV technology from the slow growth in the market rate. The limited awareness and expertise, many architecture builder and the consumer are unaware of the BIP benefit and the design integration technology. So that is also the another challenges from there. Then dependence on the import. So the limited local manufacturing capacity will be taking the higher cost and the supply chain availability and a lot of dependency in the import side. So we will importing a lot of material related to from this thing. And the another challenges is the technical and the regulatory hurdles. So a lot of fire safety, structural load, the building code will be required the clear standard and certification from there. So these are the things will be required from the system. So these all are the major the challenges we will identify from the barrier of the BIPV system in India. Now, when we're talking about the BIPV system and the traditional rooftop, so there is the features from the different way. Now, the integration, when we're talking about the BIPV, so we will discuss about the different type of building envelope like the roof and facade. And if you're talking about the traditional rooftop, so you just mounting your module in the total roof. But in the BIPV, you can use the roof and also you can use the facade of your system. If you're talking about the functionality, so this particular BIPV has using the dual purpose. So this is using the building material plus the power. But if you're talking about the simple rooftop system, so it is only depend to the energy generation, but it is not given to the any building material from the system. So this is also a very important functionality of the BIPV. If you're talking about to the aesthetic, so highly customized and the visually seamless, and this is the rooftop generally nobody has can see from there. So this is also a very important part from there. The installation part, so the BIPV, the complex integrated into the building design. But if you're talking about the rooftop, so it's easier and it will be the retrofit friendly system. But there is some complexity in the installation of the BIPV system. If you're talking about the cost, so the BIPV is the higher upfront cost, but offset material from there. And when we're talking about to the traditional rooftop, so there is a lower upfront cost from there. If you're talking about the space efficiency, so in the BIPV, you have not required any land from there. So this is the land neutral system, and it is ideal for the urban area. And if you're talking about a rooftop system, we have required some roof and other spacing from that particular location. So this is the basic difference between the BIPV versus the traditional certification. Now we come to the standards of the system. So we have a coming from the different type of standards are using to the BIPV system. So the first standard is the IC 63092. This is the basically from the photovoltaic building, and it is a requirement of the building integration of photovoltaic module. The second, standard is the part two. So this is the two standard in a part one and part two, and the both has using to the building integrated of photovoltaic system. The third standard has required the IC 61730, which is basically using from the safety utilization of the system. So if your system is the safe or not. So with the help of that, you can clarify that my system is the safe or not. Now the IC 61215, this is the particular IC which is the basically useful for the design qualification and a type approval. What are the test requirement for the system? How your module will look like? How your module will be generated with the maximum amount of energy? So these are the things will be done from here. Now, the another thing is the ISO standard, the 18178. This is the glass in building. So this is the basically cover to the laminated solar photovoltaic glass which is using to the building. Then we have to the ICTS 61836. This is the basically from the energy system of the standard. So this standard is also useful from the BIPV parts. Then we have the Korean standard. So this is basically useful in the Korea. But if you have learned this standard, so you will also getting some idea from there. Apart from that, we have a two more standard of EN 50583, which is basically used from the photovoltaic building, the European Union, and the part two is also using from the EN like the European Union. So this is the major standard will be available in the system, and with the help of if you follow this standard, so we will making our system in a very efficient and a prominent way on the industry. Now, when we're talking about the IC 63092, so this is the different type of category they have written there, like that the category 1, so this is the slow proofing will be there. The category B, there is a slow proofing, but there is some roof integration from there, so you can see that this particular system. The category C, there is the vertical is scoping from there, so you can using to the vertical way from your system. Then category D is the is also from the from the system, and the category E you can use to the different type of window from the system, and with the help of that utilize of your system. So these are the different standard have utilizing of the BIPV system on the sector. Now, when we're talking about to the role of BIPV in Indian green energy building sector growth, so this is the important part. So when we're talking about the construction industry, so it will be rises around 8.5 to 9% from the last year of the data, and this will be also driving the lot of the raw material and the costing from there. The another thing in the building sector, the high-rise commercial building will be coming from there. Then the larger facade of roof ratio will be also utilized from there. So with the help of BIPV, we have utilizing from this growth from there. Then after that, the India improving the green building standard and the ranking second the globally for the LEED certification in 2022. There is the 323 project will be cover around the 10.47 million square meters. So 2022, India has coming the world ranking 2 in the globally in the LEED certification. So we have a lot of building will be making from the BIPV system. And if you're talking about to the India homegrown green energy rating, so we have to the GRIHA, that is called the green rating of integrated habitat assessment. Apart from that, we have the JAM portal from there from the system designing. And if you're talking about the GRIHA, so around 1,700 GRIHA projects rated under this particular green building initiative from the Indian rule. So these are the things will be done from here. Now, the designing with the simulation software. So earlier I will told you in the design part how can you design the system. So this is some software name like the PV Soul Expert. So with the help of that you can design the system. The SAM, this is called to the System Advisor Model. So you can also utilize the designing from the system. Then the EG Solar, another software. With the help of that you can making the system. Then BIS MS Solar PV systems. So with the help of that you can making to the different building integration of that particular area. So this is the different designing simulation software will be utilizing on that particular location. Now we come to the important part where we will see that the notable project from the BIPV project in India. So one is the Citrus data center from the Navi Mumbai. Then we have to the Renewable Energy Museum, the Vijayawada, Malabar headquarters, and the Coimbatore. So this is the some photograph. Can anyone tell me this? Anyone from Delhi here? Anyone from Delhi here? Okay, so no issue. So this particular building from the India Paryavaran Bhavan. So if you visit to the Jorbag area, so this is the entire roof will be utilized from the solar energy, and that is a call to the BIPV system. This is the Sujalon One Energy Earth Pune system. So where you can see that all the glasses are the making from the BIPV system. This is the Rajiv Gandhi International Airport, the Hyderabad. So if you see this particular facade, so this all the facade will be made by the BIPV system. This all are the solar panel from there, and with the help of that, they will making the system. This is the Indian Institute of Science Bangalore area where they have using to the different type of solar energy in their glasses and the roof from there. Now, the apart from that, we have the Kolkata International Airport. So, if you go there, so if you see the this particular area and the upper area in the roof side, so this, both the way you can find out to the BIPV system from there. Then we have the U Solar Central Data Center. So the entire building will be made by the BIPV system, and this is the one of the biggest example in India. The entire system will be using to the BIPV system on that particular area. This is the Sahibabad railway station. So there we can also using to the different type of solar panel in the train side. And this is the one of the best example from the BIPV building in the recent time. This is the Atal Akshay Urja Bhavan where the Ministry of New Renewable Energy office is there, and this is the entire campus. You can see that this all are the BIPV integrated system has utilized from this particular location, and with the help of that, in a daytime, lot of energy saving will be happening on that particular building. So this is the typical example of the Indian notable project. Now, if you're talking about to the international perspective, because this all are the technology will be transferred from the international side, so we will the depend to the European country. So we inspire to the European because European country has working in the BIPV the more than 40 years of experience, and they have developed the strong BIPV ecosystem and the learning from the European success. Then after that, we have also do the integrated building and skilled workforce from the different technology advancement support center and the different type of university and application system where they have founded in 2014 in Switzerland, and with the help of that they will be doing a lot of R&D, lot of manufacturing and a lot of development from their particular center. They have also done the long investment around the 150 commercially available BIV product where the real solar architecture and the competitive industry blending the construction and the renewable energy in a both the ways. So they have a 150 commercial building in the entire Europe. So if you visit the Europe, you can also see that BIPV system from there. Apart from that, the international BIPV experience, they have making some task group, the task 15 group from there, and with the help of that, they have also a study of the different type of challenges, architecture, and the supporting of the urban development goal of the system. So these are the initiative we will discuss from there. Apart from the Europe, the Switzerland has also the very emerging market in the architecture in the past 20 years, from the 2006 to 2023. So a lot of projects will be coming there. If you're talking about the BIPV, so around the 41% of the BIPV system will be coming there. And if you're talking about the 2018 data, so this will be the very big achievement from the Switzerland. They have utilized the BIPV in the prominent way of the system. Now, I will just give you some glimpse to the BIPV system. This is the opaque facade from the Sonovation system, and this is the transparent glass you can using from here. So this particular glass is a transparent, but if you see in the far away, so there's a different color you will find out from that particular location. This is another example of the semi-transparent glazing crystalline silicon model, and this is the taken from the AdTech solar company. So this all are the system will be given to the light in the daytime, and this will be minimize a lot of electricity in a daytime period. This is another example from the switcher where we have using to the car parking area. So in the NIT Patna, you can also use into the car parking area, and you can also develop as the BIPV system from there. And this is a very much state of art the facility from that particular location. Also, apart from that, we have the building from the Switzerland. So you can see that the entire building we have using this black color is the solar module, and all the solar module will be generated to the electricity on the daytime. Apart from that, you can also see that in the building premises, all the black color and the gray color has utilized from the energy generation from there. Now, this is the picture from the France. So you can see that if you're using to the upper side in the roof, and with the help of that, you can also utilizing to the BIPV system. This is also the retrofit system from the Spain. So you can see that they have also utilized to the solar module from there, and with the help of that they will be minimize the lot of the daytime electricity, and it will be also growing the lot of energy efficiency from their building. This is the another concept. So this is a very genius concept from the various alternation, and this is a call to the diamond pattern from the system. So with the help of that, you can see the different system from there. This is another example. So sometime they have making to the container box as a BIPV. So you can see that this is the typical example of BIPV. They have make their door as the BIPV system, and with the help of that, they can utilize the system. This particular location in the inside of that particular diamond pattern structure, and you can see that in the daytime, entire location as the BIPV system has working in a prominent way. This is another example. The outside is a look like this way, and if you see from inside, so this is the look like this way. So this will be utilized to the shading part from the inside location, and also it will be generated to the maximum amount of energy from there. So this is the international perspective. This is the BIP installation from the Canada. So Canada has also doing a lot of project from there. So this is a different orientation, different type of technology you can utilize from there. Then this is the international perspective. This is the night view of the building. So you can see that in a Switzerland building, and you can see that all the solar module is here. And in the night time, the all the whatever the power will be generated from there. So the same power will be utilized in the night time of that building, and with the help of that, this beautiful image will be coming from there. So this is the effect of the BIPV system. Now this is the one of the Jew in the Vienna where they have using to the BIPV system from there, and this will be given to the full attention from the daytime of system, and this will be given a very good example. This is also the another example of the glazing of the system, and it will be utilized to the daytime of all the energy generation, because in the daytime we did not go for the normal electricity, so we have utilized the sun power, and it will be utilized our daily requirement from there. Now, this is the last topic from there. We will just discuss about some case study. What are the case study from here? So this is one of the building. This is the unwelt arena from the ISA Janati. Sorry, the unwelt arena from there. And if you see this BIP building, this is the side view. This is the upper view. And if you see from the Google Map, so this particular image will be look like in this way, and this entire roof will be making from the BIPV perspective and BIPV integration. This is the another San Antonio market which will be taken the different picture from there, and this is basically from the Spain. So you can see that this is the rooftop system is here, and in the daytime all the daylight will be coming from this location. And if you see it from the Google Map, so this location will be look like in this particular way. Now, this is the another in the Florenzo Kinderstone ground from there. So from here, you can see that the entire roof will be making from the BIPV structure. And if you see in this particular structure in the top view, so it will be look like in this way. And this is a very good in the. This is also win to the some award from the BIPV architecture, and this is a very fantastic view from that particular location. This is another view from the Kota Suva AV station from the international project. So the entire station has coming to the roof covering. So you can see that entire roof has come from the solar panel, and in the daytime all the light will be coming there. And if you see from the Google view, so this will be look like in this way. So this is the another perspective from there. This is the Tua Post Administration building from the USA, and this particular building has also installed to the entire rooftop. So this front side, this is the all the BIPV system, and the roof side is also we have using to the BIPV system. And if you see to the upper side, so this will be look like in this way. This is the another canopy. I just request to NIT Patna, you also develop the such kind of initiative in your campus, so it will be utilized to the day storage light, as well as it will be utilized to the EV charging station. And it is also saving to the shading of your parking area. So this is the initiative you can also start from in your campus. So the daytime is a look like this way, and if you go to the night time, so this whole structure is a look like in this way. So in a daytime, this will be using from the shading from the car, and also you can see here the charging station is here. So with the help of that, you can also charge your EV from that particular location. Now, so this is from my side. Thank you very much for your time. You can note down my email ID, and you can also connect me in the LinkedIn if you have any question or any doubt. Now we come to the question answer session. So if you have any question or anything, so I'm happy to give the answer to you.
Thank you, sir, for your wonderful sessions. And now the platform is open for the participants. If you have any query, any question, please ask the experts. Or if you want any discussion related to your project and research area, you can ask directly to the experts.
Yeah, any question from this presentation, out of this presentation? So anything, you just raise your hand and then ask your question.
Sir, in that pic for that Jew in Vienna,
Yeah,
there is a grid type of sunroof, like roof installed.
yes,
Like
yes.
one grid, like few grids are in blue color and other grids are fully transparent.
No, this is a look like the structure way actually. So that's why it's a look like this way. But this is all the flexible model actually. So due to some images, you will look like this way. But this all are the entire solar model from there actually.
So this solar this panel, which has a full transparent, like a 19
Yeah, this is a full
percent.
transparent, and this is the flexible also. Because if the module is not flexible, so how can you install the system? So this is the full transparent and the full full flexible model from there actually.
Is the transparency affect the efficiency output?
Yeah, so if you're using to the bifacial module, so it will be utilized in the both the way. You can utilize the system in the bifacial way, like that it will be generate the electricity from the upper side, and also it will be generate from the lower side. So this is the benefit from the both the way how can utilize the system, and with the help of that it will be generated to the maximum amount of the energy generation.
Sir, what are the materials, this type of transparent and different
No,
colors?
only the material is there. This is the very thin glasses have using there. So generally, what happen? The solar module when we manufacturing, so in the upper side we have using to the glass material. That is called to the anti-reflective glass from there actually. So in that particular the flexible module we have not using to the any glass from there, and we generally just using to the flexible module from that particular area, and with the help of that we can design our system.
So what are the types of material solar this solar
Yeah,
panels
this is the
available in
silicon
India?
material. This is all the silicon material.
In India, is this materials available?
Yeah, this material is available. Yes, we are working on the same thing actually.
No,
The
actually,
Reliance is working on the same thing. Yeah,
no, in the like in retail market, I'm saying.
retail market is available, but the demand is low, so you just requested from the demand, and after that this come to you. But now I already told you, a lot of lacking on the policy side is also. So a lot of people are not aware, but this is a very right technology in the right time. You can utilize the system, you can save a lot of electricity, and it will be good for your day and night time also. So if you're using to the such type of a structure, so it will be given to the lot of attention from your building also.
So currently, this is promoted by only Reliance or any other solar
No, this
company.
is promoted. A lot of things will be coming here. So the Reliance is also working to the one of the efficient technology. But frankly, I told you we are not coming to directly in the BIPV sector. We are manufacturing this thing. This session is a BIPV, so that's why I cover this thing for you. But we are coming in a very efficient technology in the system, and with the help of that the future maybe we will come to the BIPV, but currently we are not planning to the BIPV. We are making to the normal module, which is called to the adjective module. This is one of the highest efficient module in the entire world. If you're talking about the efficiency range, so the efficiency of the module is around 24 to 25%.
Okay, thank you, sir.
Yeah. Mr. Arvind has asking some question. Do we need any base structure infrastructure? Yes, so you will require some base structure, because that you will just consider this thing ki your module will be fixes from there. If your module is not fixed from there, and sometime the wind and the rain will be coming there, and your module will be the laptop from there. So it will be also the very challenges part for you. So for that kind of thing, you will require some base structure from there. The another question from you, the life is span of this panel. So generally, the solar module life is around 25 years. But when the module will be made by the Reliance, we will give it to the offer to the 30 years of the life span. So if you are in a 30 years, so you can use the upcoming 30 years for the solar module on your roof. Are you getting it, Arvind? Yes, Shrid. Shashidhar, yes.
Sir, these like many of the designs you showed is more complex. Even the railway station, for
Yeah.
maintenance, how do you? Yeah, hello.
Pardon? Maintaining?
So for maintenance, for cleaning purpose of these solar panels and all.
Yeah, solar panel cleaning will be required. So whenever the company has installed the system, they have also taken the O&M, that is called to the operation and maintenance. So the when they have taken the O&M, so they have the responsibility to clean the all the module from their aspect actually.
Okay, thank you, sir.
Yeah, any other question?
Anyone?
You can ask any question regarding this session or outside. There's no issue. The forum is open, so that's why I taken the small session, not the big session. So,
Sir, regarding
if
that
you have any
flexible
question, any
panels,
doubt,
I want to just know, the flexible panels and other panels are using in the PDT system, VIP system. So there is some
yeah.
efficiency related to efficiency and cost economical analysis. You can elaborate some things.
Yeah, so the flexible module, the sometime the cost will be higher as compared to the normal module. But if you're talking about the energy generation, so the yield will be the look like the similar, like that. The general module in a 1 day generate the 5 units, so the flexible module maybe generate to the 4 to 4.5 unit, not the 5 unit. But if you talk about to the concept, like the system will be the both the way in the look like in the same way, but only we have using the BIPV system, the flexible system on the roof, not the entire area. So normal BIPV module you can use to the facade or anywhere, but if you're talking about to the roof, so only the roof area you will use it to the flexible module. If your RCC structure, or if your the top area will be the very flexible, so that particular case you only use the flexible module. Otherwise, you can use to the normal module from there actually.
Okay, thank you, sir. And sir, I just want to know, in BIPT system designing, there's a facade system is a building
Yes.
structure is almost 90 degree. So in initial design
Yeah.
stage,
Yeah.
can architect and engineering can incorporate like such a angles in buildings for optimal operation of.
Yeah, generally the 19 degree, they have come to the 60 degree also. And why we have taken the 90 degree? Because the module reflection will be come to that particular angle actually. If you're not using to the 90 degree, generally what happen if you're using to the tilted condition, so the module will be generated to the higher energy. But how you make to the tilted structure from that particular location? So that is the major point from there actually. So if you're using to the 90 degrees, so means that it will be the efficient way, and the entire day it will be covered to all the solar radiation from there actually.
Sir, one thing, the solar panel that's inside we're using the facade system, the inside with thermal heat is generated. So how they control in this,
Yes.
so many example and case studies, how they control the thermal comfort in the inside of the buildings.
Yeah, so they have using to the chiller from there, and that chiller will be running by the solar energy. So whatever the energy generation at the outside, the same chiller has working to the inside. But if you're talking about to the structure, so sometime you can observe that if you're using to the facade system, so due to the shading effect, it will be minimize the temperature. The temperature difference, the outer and insider, is the lower as compared to the normal system actually. But whatever the system you have putting on the side, the same chiller system will be utilized from that particular area. So that will be cooling will be happening from there. So that is called to the passive architecture. I think someone expert has explained you that is called to the passive architecture, and with the help of the passive architecture, you will minimize the all the heat load from there actually.
Sir, is those softwares you have showed in the screen are open or purchased, sir?
Yeah, some software will be the free of cost, and some are the chargeable basis. So a lot of software will become like the SAM software will become to the free of cost. You can just download from there, and you can utilize the software from that particular location.
Sir, just a little point on my side. You already talking about
Yeah,
the challenges in integrating VIP system in India, but related to urban residential
yeah.
building, especially there is some design and cost. So you can throw some light on.
Yeah, so if you're talking about to the normal system, the concrete and the normal raw material cost will be higher. But if you're using to the BIPV system, that is the two advantage. One is the minimize the land area. The second one is the energy generation, and the third one is the cost effective. yes, you are right. Ki initial way, the costing will be higher. But if you come to the some time like the 5 years or 10 years time of period, you will saving lot of money as compared to the normal system. So that will be the very good and prominent things in the country like the India also.
And sir, something that is there are number of policies that is Surya Ghar Yojana. Already government has many initiatives,
Yes,
but
yes,
people
yes.
are not adopting it. So
Yeah, because the
as
people
per
are
you
not
elaborate
aware
the
it.
different
Because
policies.
yeah, go ahead.
Yes,
Yeah, generally in my thing is that the lack of awareness from there actually. So people are not properly aware of this particular scheme, and who have aware this scheme, definitely the lot of people have using to this particular yojana, and the government of India has targeting around the 1 crore household, around 1 crore household will be using from this particular technology, this scheme from their houses actually, and is a good point around the 10 lakh home is already covered in the last 6 of months. So this is all are the initiatives happening from that particular side.
sir. The government is already giving the incentives, but after that, people are not interested in this. So there is some changes. Yeah, government think about that. It make some another
Yeah, I think
inter
the
spreading
if you're
awareness.
talking about the 1 kilowatt of system, yeah, if you're talking about the 1 kilowatt of system, the costing is 55,000 rupees, and the government has given the 30,000 to you in the return basis. So I think 25,000 rupees is still your challenges. So we cannot say anything for anyone actually. Because it has saved a lot of money actually. If you're talking about to the frequency cut like the UP and Bihar, generally the lot of power cut will be happening in a summer month. So that particular technology is good for that particular location actually.
Thank you from my side. Participant, if you have any query, please ask the question. Then after that, we go towards the end of the sessions.
Sir, what is the experience by this rotatable solar panels or auto tilted solar panels?
Yeah, so this is the two types of panel will become. One is the fixed structure panel, and another is the flexible structure. So the flexible structure means they have through different type of orientation. Okay, so one is a come to the single orientation, and another is come to the dual orientation. So whenever you're using to the orientation type of system, so it will be generated to the maximum energy yield, but due to the cost concern from there, so the people will be not going from that particular area because the costing will be raises around the 50 to 20% of that particular case. So the people are not adapting to that orientation type of technology. So this is the clean steel from there. But if you're using to the orientation type of technology, definitely it will be given to the higher energy yield as compared to the normal system.
Sir, is that like manual seasonal rotation with manual intervention is possible?
Yes, seasonal intervention is possible, but it is only possible to the small structure. But if you're talking about the megawatt structure, like the 100 megawatt of system, so entire the 2 months will be gone away from the manual adjustment of the system actually. So that will be also the concern. If the system is a 1 kilowatt, 2 kilowatt, 10 kilowatt, 100 kilowatt, you can do the manual adjustment from there. You can utilize the different type of tilt angle like that. The summer month, my tilt angle 45 degree. The winter month, my tilt angle in a different way. So that tilt angle will be different on the different way location from there actually. You can use this manual adaptation from your structure. There's a no constant rule from there actually.
Okay, thank you, sir.
Okay, welcome.
Thank you, everyone. Now we moving towards the concluding of the sessions. So thank you all for your active participation in the today's session on BIP and solar policies and regulatory frameworks delivered by Dr. Yogesh Kumar Singh. And we are grateful to Dr. Singh for enriching and insightful presentation on building integrated photovoltaics. And the session offered a deep understanding of BIP design, covering its various stages for site analysis and site sizing of material integration, electrical inflation, and performance valuations. Dr. Singh also light on the existing solar energy policies, regulatory frameworks, and incentive mechanism that are the crucial for increasing the adoption of BIP in Indian context. And importantly, the session in phasing the critical role of BIP in green building developments. That is, BIP not only reduce the dependency on fossil fuels, but also contribute to energy efficiency, reduced carbon footprints, and better building performance, aligning with global sustainability standards and green certification systems like GRIHA and LEED. The discussion also referred notable BIP projects in India, such as Indira Paryavaran Bhavan in New Delhi, and some other example already shows in their presentations, which demonstrates the successful real-world integration in the BIP technologies. And we thank Dr. Singh for sharing his expertise and all with all participants and for their engagements. And now we look forward to continue involvement in upcoming session of the FDPs. And thank you, sir. Thank you so much for a wonderful sessions. And a little announcement for the participants that the next session will start at 11:30.
Okay, thank you, Dr. Ravi and entire your team. Will be successful organize this training program. All the best to all the participants. If you have any question or any doubt, you just reach out to me. You can connect me in the LinkedIn and my email ID with you. If you have any technical question, anything, if you have, you just reach out to me. You can take the email ID to Dr. Ravi as well. So he will provided the detail from my. So it was a good interaction session. I hope a lot of question will be come from you. Don't know
Yes,
why the people
yes,
are not asking the question. Maybe the morning session, so the people are not too much active. So that's good. The Sridhar Reddy has asked a lot of questions. That's good. This is a very good quality of the learning perspective, because when you're learning from the both teams, so it will be given a lot of confidence. Means कि जो आपका instructor है उसको भी पता है कि yes, whatever the you have a deliver, the someone has delivering this thing. So thank you very much. The Dr. Ravi.
thank you, sir. Thank you so much. And now with this, we close these sessions, and the next session will start at 11:30. Okay, thank you, everyone.